Once again, when graphing this or any other square root function, you want to make sure you know where your domain is. You want to make sure you're not wasting time plugging in x values that aren't going to give you real numbers. So the way to figure out that is to set whatever's inside the radical as greater than or equal to 0. Because you can only have numbers that are 0 or greater inside the square root if you're going to get a real result. If you solve this for x, you end up with the expression, or the inequality, x is greater than or equal to a half. So a half would probably be a pretty good x value to plug in. In doing so, you get 3 times. 2 times a half is 1. Take away 1 is 0. So 3 times the square root of 0 gives you 0. Then you probably want to plug in some x values that are to the right of 1/2, since x is all the stuff greater than or equal to a half. So if we plug in 1, we're going to get inside the square root, 2 times 1 is 1, minus 1 is still 1. Square root of 1 is 1, 3 times it is 3. If you plug in 2, you'll get inside the square root, 2 times 2 is 4, take away 1 is 3. A calculator will tell you that 3 times the square root of 3 is pretty darn close to 5.2. If you plug in 3, inside the square root, 2 times 3 is 6, 6 minus 1 is 5, and again, a calculator will tell you that rounded off to the nearest tenth, 3 times the square root of 5 is about 6.7. We'll try plugging in 4 here. We're getting pretty high off the graph. We'll see if we still have something on here when we plug in 4. 2 times 4 is 8. 8 minus 1 is 7. 3 times the square root of 7. It's about 7.9. Let's see what this gives us. We plot these points. A half, 0 is right here. 1, 3 is here. 2, 5.2 is about there. 3, 6.7 would be here. And 4, 7.9 would be about there. This is an inequality, so we don't want a solid line here. We want a dashed line. It'll go forever to the right. It gets a little flatter as it goes, as you can already tell with the points we have plotted. And then we have to shade either inside or outside that curve. So let's test an ordered pair. I'm going to use the point, I don't know, I'll use 0, 1, so that's to the left of the curve. So 0, 1, that's my test point. If I plug in 1 for y, and 0 for x, I get 2 times 0 minus 1, which gives me an imaginary number in the radical. Which means I'm probably shading inside the square root. That would be your final answer.